So I wanted to record a short video on how to get started on this maze activity in case you are struggling at all. And so I want to go through a couple of problems. So you start over here where it says start, and then you got to find, what it links to for the next problem. And a lot of these you're going to be changing to radical form, which it says up here. Rewrite each expression in simplest radical form, and then navigate through the maze. So obviously we're going to start here and hopefully end down here. And you're going to have to do both sides of this, but this side here where it says version 1 on the bottom, this one's a little bit harder, so I want to go through a couple problems with you. And you'll probably need your exponent table to do some of them as well. So the first one, I'm just going to keep going back and forth between these two. We have the x to the 1/2, I think is what it is. That's where we're starting, x to the 1/2. We're going to write that as a radical, which hopefully you know is the same thing as the square root of x. Like there's a little 2 here. So that would make us go from here, and you would shade this. You just take a pencil or a color pencil, shade this in, shade this, and go to the right. And now we're going to do 27x to the 1/3. Now you should be writing these problems like number 1, number 2 on a lined piece of paper, and you need to show all your work for this. 27x to 1/3. And then we do the problem. So this means that you have 27x in the parentheses, which means everything gets the 1/3 power. So you could rewrite this as the cube root of 27x. All right, that's what this means. They're both contained in there. Of course, you could also then simplify this a little further and actually do the cube root of 27. Which is 3. And then we have the cube root of x, but you can't do anything with that at all. So the answer to that would be the 3 times the cube root of x. So that would take us up. So we're going to go from the left to the right, and then go straight up. That's our answer here. Then we have 7x to 2/3. So this is our third problem. 7x to the 2/3. Now this one does not have parentheses in it, right? So the x is the only thing that has the exponent on it, the 2/3. So the 7 just kind of stays where it's at. The 2/3 that we have is going to change to the cube root of x squared. And you could ask yourself, could you go further? Like, does 3 go into 2? No, it does not. So it looks like that's going to be our answer. So it looks like we're going to go, we have a bunch of options here. It's going to go this way, up in the corner. And now we're up to x to the 3/4. So x to the 3/4. Changing that to a radical form would be the 4th root of x cubed. And it looks like we don't have enough to go into 4 goes into 3 0 times, so that's our answer. That's going to make us go to the right. Now we're at 2x to the 7/3. I'm doing a lot of these with you. 2x to the 7/3. Is this in parentheses? It is, okay. So this would be rewritten as the 3rd root of, and I'm going to keep this in here as 2x to the 7th. So we're going to go a little bit further. I just put the 2x inside there, and the 7 goes on top. That's the exponent now. This is the cube root of the 7 goes to everything. 2 to the 7th, x to the 7th. So the 7 goes to both things. And then we have the cube root. Oh, wait. I guess we can stop there and actually start simplifying this. So do it to the exponents. 3 goes into 7 2 times. So 2 squared. All right, you can count by 3s. 3, 6. Can't go any higher. So there's going to be 1, 2 left on the inside. So I'll leave a little space here. And on the outside, we have 2 squared. And how about the x's? 3 goes into 7 2 times as well. So we have x squared out there. And 1 left over. So it looks like we're going to get 2 squared, which is 4x squared, times the cube root of 2x. Okay, 4x squared, which would be this one here, times the cube root of 2x. All right, we'll do one more. 2 times 8x to the 1/2. Now this one actually has a 2 on the outside parentheses, and the 8x is on the inside of the parentheses. So you have to make sure you write that down correctly. So this is number 6. 2 8x to the 1/2. Okay, so we can change this. The 2 stays as it is, but the 1/2 goes to everything. Or in other words, you could write it as a square root of 8x. So this one would be the type where you have to actually break apart 8 and find a perfect square in 8. That would happen to be 4 times 2. 4 is a perfect square. You can do the square root of 4. So we have 2, and then we have the square root of 4 times the square root of 2x. I'm just breaking apart the 4 and the 2, keeping the x with the 2. Here we have 2 times square root of 4, which is also 2, times the square root of 2x. These two come together, you get 4 times the square root of 2x. I think that's all we can do. And that's this way down here. Now we're down to 125x to the 10 over third power. And so we did how many? 1, 2, 3, 4, 5. We did 6 problems together. And now you're on your 7th one. Eventually you'll make your way through this maze and get down to the end where it says end. Okay, the other side. So let's go ahead and erase this. Whoops. The other side says rewrite each expression in exponential form. So this one's actually a lot easier, and you'll see, because all you're doing is just changing it to an exponent. So here we're starting in the middle. It's the square root of 3x. We're changing it to an exponent. These ones you may not have to show work, but the other page you have to show work for everything. So you don't have to show work with these ones, but if you want to, you can. The other one the other side, you have to show work with line piece paper. This would change to, remember it's 2 there. This would be like 3x to the 1/2. Now, we have to be careful here because both of these things are in the square root. So we need to include a set of parentheses, which you'll see that happens often on this specific maze. So we're not going to go down. We're going to go to the left. So we'll color this in and then shade to the left. Now we have the 4th root of 16x to the 3rd. 4th root 16. But sometimes you can actually simplify this, like you can do the 4th root of 16, which I think that's what they want you to do here. So we'll change the 4th root of 6, so you can actually split this up and do it this way. Right? 4th root of 16 is on the table, on your exponent table. That's the number 2. And then here you can't do anything with it because you have 4 and 3. 4 does not go into 3. So we'll just change this into an exponent of 3/4. Remember, this numbered here, the 4, always is in the denominator. 2x to 3/4. So that would be, careful which way to go here. It's taking us up. Up this way. All right, we have one more here. Maybe I'll do with you. So we have cube root of 6x squared. Right? Yes. Now this 6 here cannot be broken into anything that has a cube root. So this one you're really just going to change into an exponent. Just remember to put parentheses around this. And we don't have anything going in for the x's either. 3 doesn't go into 2. So we're going to keep this 6x squared, parentheses, raise it to the power of 1/3. So 6x squared to the 1/3. And you're going to keep doing this and hopefully make your way through this maze till you get to the end in the corner here. So this one takes a left, up, and then to the right. So now your options are probably not to go back to the start, probably to go diagonal or to the right. So you're just going to change them all to an exponent form. And if you can simplify the number, which we did with 16 here, you can do that. But a lot of these you're not going to be able to simplify. You're just going to change it to an exponent. This one here, you would change to x to the 3/5, which is obviously this direction. So I gave you 1, 2, 3, basically 4 of these problems. Now you're down here. Simplify that. This side is a lot easier. It doesn't take as much work besides this number 2. So hopefully that's enough examples that I showed you to be able to finish both sides of this. And then for the homework on the back of the notes from the day before, You're going to be doing the evens of those, I believe. Again, you have another piece of lined paper. Just do it on there. All the work, because there's not enough space to show the work on the actual homework. And this should be done for tomorrow.